Hello everyone, and welcome back to our discussion about the properties of trigonometric function. So the last time we discussed about this is about uh the relationship between sine and cosine in terms of having the same value, right? So if you recall, sine of theta is equal to cosine of 90 degrees minus theta, and cosine theta is equal to sine of 90 degrees minus theta, right? So here what we're going to do is we will discuss another property of trigonometric functions, which is the even and odd functions. All right. So without further ado, let's now begin. So even and odd trigonometric functions. So how would you know if the function is even and the function is odd? How would you differentiate the two? So let me give you like a simple example. Suppose I have a function here, a polynomial function to be particular. Let's just say this is x squared minus minus 1. Okay? Now, if I would substitute negative x in this function, meaning I'll evaluate this function with negative x, what will be the answer? So I will put negative x in here. So this will be replaced as negative x squared minus 1. So if you're going to simplify this one, you will have x squared minus 1. Now take a look these two results or these two functions rather. So in a given function, we have x squared minus 1. And in the second function, where we, oh, wait, sorry. And in the second thing is we substitute negative x in this function, the answer is the same, right? So there's no change of sign. So if there's no change of sign, this is what you call even, okay? If there's no change of sign, all right? Now, how about this one? If I have g of x is equal to, let's just say, what's the best example I can give here? Let's just say x cubed minus x. Then I will evaluate this function of g with negative x. So that means I'll replace this x with negative x. So negative x raised to 3 minus negative x. Negative x raised to 3, the answer would be negative x cubed. Here, negative times negative, we will have positive x. Now take a look. Oh, sorry. Now take a look at these two. Okay? This one and this one. As you can see, all terms here have different signs. So initially, it's positive x cubed and negative x. In here, it's the opposite. Negative x cubed plus or positive x. So meaning all terms change its sign. So therefore, this is what you call as the odd function. But what if some change, but some or at least one don't? Like for example, let's just say h of x is equal to x minus 1. If I would substitute negative x here, I will have negative x minus 1. Now look at the expression here. Positive x, negative 1, negative 1. Only these two change. So is it even, odd, or what will be the perfect description for this one? The answer here would be neither, right? The answer here would be neither. So in here, what we just learn or rather discuss right now is basically even and odd functions. And we can apply it in a trigonometric function. Okay? So here, first is we have sine, cosecant, tangent, and cotangent. Sine, cosecant, tangent, and cotangent are odd functions. Okay? Sine, cosecant, tangent, and cotangent are odd functions. Cosine and secant, they are even functions. Okay? And here, let's have a short recall again. The function is odd if we substitute negative negative x in the function, we will have all signs. What? All signs are change, or we call it as negative of f of x. Basically, when you see this one, negative f of x, meaning all signs are changed. Okay? Wait. This sounds wrong though. Wait. Let me fix that. All terms change its sign. Okay? Just like what we discussed earlier, like the example before. Then here, the function is even if when we substitute negative x to the function, it will not change. Okay? So that means in here, in here, the answer is just the same. Okay? Just like what was that before? I think that's uh x squared minus 1, right? X squared minus 1, right? If you substitute negative x here, the answer will still be x squared minus 1. So meaning, not all, I mean, uh, not all the terms change its sign. Okay, not all. Okay? In fact, they all remain the same as its initial function. Okay? So, with that, we can relate it here. So here, for the sine, cosecant, tangent, and the other functions, this is what it looks like. Okay? So here, if for the odd functions, we have sine, cosecant, tangent, cotangent. If here in sine, the input is negative, the answer would be negative sine theta. For cosecant, if you have an input of negative, you will have negative outside, then cosecant theta. The same implication here as well. Tangent of negative, what happens is we will have negative outside, then tangent theta. Okay? And lastly, cotangent of negative, then is equal to negative cotangent. So this is in fact odd, okay, for these four. Now, for the even, you have a negative input, still, the answer is still the same. It will not affect its initial function. All right. Second of negative theta, it's still the same. All right. What even if it's negative, it will not affect the result overall. So negative theta, the answer is still positive theta. Negative theta here, the answer would be the same as having a positive theta. All right. So basically, these two are even functions. So let me give you some examples. Let's just say I have sine of negative 45 degrees. This one, if you're going to use your calculator, sine of negative 45 degrees, this is negative square root of 2 all over 2. Okay? Now let's try to prove this one with this. Okay? So sine of negative 45 degrees is equal to negative sine of 45 degrees. So here, sine of 45 degrees is square root of 2 all over 2. But since we have negative outside, the answer is negative square root of 2 all over 2. See? Now, let's try another example. Let's just say we have cosecant of negative 30 degrees. So, in here, okay, we can apply this property here. We can have negative cosecant of 30 degrees. Okay? What is cosecant of 30 degrees? So cosecant of 30 degrees is actually 2. Okay? And since we have negative outside, the answer is negative 2. Or if you don't understand how I got it, remember the reciprocal, sorry, wait. Remember the reciprocal identity for the cosecant, right? Cosecant is the reciprocal of sine. So meaning we can have 1 all over sine of 30 degrees. And remember that the sine of 30 degrees is 1/2. And this is a complicated fraction, so we can simplify this one. So we can have negative 1 times the denominator, but the positions here are switched. So we will have 2 all over 1. So the answer here would be negative 2. Okay? See? That's it. Other examples. Let's just say we try tangent of negative 90 degrees. So remember that tangent theta and tangent of negative theta is just the same as negative tangent of theta. So tangent of negative 90 degrees is just the same as negative tangent of 90 degrees. So here, tangent of 90 degrees. Okay, tangent of 90 degrees. I think that would be undefined. Okay, let's take a look. Remember that tangent is just the same as sine of 90 degrees all over cosine of 90 degrees. So what is sine of 90 degrees? That is 1. All over cosine of 90 degrees, it's 0. Since we have a denominator of 0, that would result to an undefined answer. The answer here is undefined. Okay? Let's have example for the cotangent of negative theta. So let's just say I have cotangent of, let's just say, negative, let's try different number. Okay, let's just say, uh, we try something that is not special. So let's just say 20 degrees. So here, remember, if we have a negative angle here, that means we can have negative cotangent of 20 degrees. Okay? So here, uh, since this is not special angle, we can use calculator here. But remember that in a calculator, usually we have only sine, cosine, and tangent. Cotangent, cosecant, and secant are not usually given in a calculator. So here's what we're going to do. We will get its reciprocal identity. Remember that cotangent is just the same as 1 all over tangent. So hence we will have 1 all over tangent of 20 degrees. Okay. So let's get our calculator. Negative 1 all over tangent of 20 degrees. This is just negative, approximately negative 2.74. Okay? And that's it. Okay? Now let's try for cosine and secant. Okay? So for cosine, let's just say we try cosine of negative 135 degrees. Okay? What is negative of 135 degrees? So this one, this is basically square root of 2. Wait, no. This is basically negative square root of 2 all over 2. Wait, really? Let's take a look, okay? If we're going to use our calculator, cosine of negative 135 degrees, the answer is negative square root of 2 all over 2. Okay? But you see, remember that cosine of negative theta is this the same as cosine theta. So let's try cosine 135 degrees. So what's the answer? So here, the answer is still negative square root of 2 all over 2. So they are in fact the same. Negative or positive, as long as they're the same in terms of number, they are in fact the same. Okay, that is for the cosine. All right. By the way, if ever you are, I told you the technique before. Like for example, you do not know the value here. Remember reference angle? Do you remember that? Apply that. Okay, reference angle. Then, of course, you need to know the position of this given angle. So, for example, in this case, we have 135 degrees, right? So, where's 135 degrees? So, it goes from here going there. Okay? Because remember, here in a graph, we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So basically, this one whole revolution. So if we're going to ask ourselves, where 135 degrees located, it's actually between 90 degrees and 180 degrees. So it's in the second quadrant. And remember that in the second quadrant, the x values here are negative, but the y values here are positive. Okay? So if you're going to get the x value here with the use of a trigonometric function, you will use cosine, right? But remember, if you're going to get the x value on the second quadrant, the answer would be always negative. Okay? So first and foremost, you can get its reference angle, basically the angle here. Okay? So if you're in the second quadrant, remember that if you're in the second quadrant and you want to find sorry again, the reference angle, you will subtract 180 degrees by the given angle. So we have 180 degrees, 180 degrees minus 135 degrees. So you will have 45 degrees. Okay? So this is 45 degrees. So what is cosine of 45 degrees? Okay? But remember, we are the second quadrant. So meaning x is negative. And we use cosine to find our x if we have a given angle. So therefore, this is negative. So what is cosine of 45 degrees? It's square root of 2 all over 2. Okay? That's it. So yeah, basically that's it. Okay, this is just a additional information in case if you're having a hard time to find uh the what's that again? The value of a given function. Okay? Now lastly, how about if we use secant? Okay, of secant of negative theta. Okay, how about that one? So it's just the same as for the cosine. Okay? So let's just say I have secant of negative let's just say 0 degrees. Okay? So this one, wait, going back. So yeah, negative 0 degrees. Actually, there's no negative 0 degrees, eh. There's no such thing as negative 0 degrees. Let me just change that. Let's just say uh 30 degrees, much better. So this one, we can just simply rewrite this as secant of 30 degrees. Okay? So if you're if you're wondering what would be the result for this one, this is actually 2 all over square root of 3. Wait, am I right? 2 all over square root of 3. No, it's actually 1 half. No, wait. Let me just check. Let's just say this is 0, 1, 2, 3. No, it's 2 all over square root of 3. Okay? So this is 2 all over square root of 3. If you're going to use the calculator, uh, here, we can just get its reciprocal identity. So remember that secant is just the same as 1 all over cosine. So we have cosine of 30 degrees. So here, we have 1 all over cosine of 30 degrees, square root of 3 all over 2. And here, we can simplify this fraction, copy the numerator, then multiply the denominator, but you're going to switch its sides. So we will have 2 all over square root of 3. And that's the same thing here. Okay? Because this is just the same as 1 all over cosine of negative 30 degrees. And remember that if we have a negative angle here inside of the cosine, we will have positive. So we will have 1 all over cosine of 30 degrees. So remember that cosine of 30 degrees is square root of 3 all over 2. And if we're going to simplify, the answer is 2 square root of 3. So overall, these are like the uh, properties of a trigonometric function in terms of its even and odd function. So here, this is actually very useful if you're having a hard time in, let's just say, in getting the value of a trigonometric function. So, for example, let's just say you have sine of, let's just say, negative 210 degrees. Here you can solve this one by finding its coterminal angle. And to be particular, finding the coterminal angle in between 0 degrees up to 360 degrees. So meaning you'll find the angle, equivalent angle for this one in this interval so that you will know the, what do you call this one, the result. Okay? So here, if you're going to get the coterminal angle, and as I said, the recommended way is between this range, you're going to add this one by 360 degrees. So 360 degrees plus negative 210 degrees, you will have 150 degrees. Wait, am I right? 150 degrees. So here, we can have sine of 150 degrees. And sine of 150 degrees is just 1/2. Okay? So here, we can just apply a property here instead. Instead of having sine of 150 degrees, we got that by getting its coterminal angle. Let's just try this property. So remember that if we have a negative value here, we can just put negative outside. So negative sine of 210 degrees. So what is 210 degrees? So 210 degrees, if you're going to get the value for this one, it's negative 1/2. So here we have negative times negative. The answer is 1/2. See? So it is in fact useful. So here it's up to you if you're going to use coterminal angles or whatnot, but at least you know the techniques. Okay, especially for other functions such as cosine and secant. Okay, like another example. Let's just say we have cosine of negative 300 degrees, for instance. Okay, so here, if you're going to apply coterminal angles, then get its reference angle. Here, I think I do believe the answer is 1/2, right? Let me take a look. If you're going to get its coterminal angles, and then you, actually, yeah, you know what? Let me just do it there, okay? If you're going to get the coterminal angle of negative 300 degrees between 0 degrees and 360 degrees, you will have cosine of 60 degrees. Okay, you'll have cosine of 60 degrees. All right, and cosine of 60 degrees is just simply 1/2. Or you can again do this instead. Okay, we have a negative angle here inside of the cosine function. What can we do is we can just have cosine of the positive version of this angle. So we have cosine of 300 degrees. So what is cosine 300 degrees? So this is also 1/2. See? See, guys? So here, this is just like another method that you can apply in terms of finding the value of a trigonometric function. And that will be all, guys. All right? So see you soon. All right? Take a break for a moment. Then we will discuss the last property of trigonometric function.